Okay, we'll be going over pre-algebra worksheet 805, more with functions now. Problem number 1. If D equals M over V, the value of M when D is 3.6 and V is 1.7 is. So this is substitution. We substitute 3.6 in place of D, and we substitute 1.7 in place of the V. An easy way to do this problem is to make this a whole number over 1. Cross multiply. 1 times M is M, and 1.7 times 3.6. $6.12. So M is 6.12. Okay. Moving on to number 2. The solution to 5x minus 4 plus 7 equals 18 is what? Write it out. First things we need to do is combine like terms. Negative 4 plus 7 is 3. So this becomes 5x plus, because it's a positive 3. Next, we need to do 2 steps. Hopefully you remember the 2 steps. What is the opposite of adding 3? Subtracting 3. That would cancel these out. That makes this a 15. And the second step is do the opposite of multiplication, which is division. Divide both sides by 5. Canceling this out and making this a 3. X is 3. Okay, problem number 3. A rectangle has a length of x plus 3 and widths of 5. The total perimeter, if you add all this up, you get 42. So let's write an equation. Okay, first you need to know the formula for perimeter is 2 lengths plus 2 width is perimeter. So 2 of our, oops, I swapped this. This should actually be the length and this should actually be the width. But the order isn't important because it's adding. So 2 widths comes out to 10 and 2 lengths comes out to 2x plus 6. We still have this plus here. Okay, now we're going to do what we did up here where we combine like terms. We have like terms here. 6 and 10 are like terms. 6 plus 10 is 16. We still have the 2x and we still have 42 over here. Okay? All right, now we're down to 2 steps. 2 steps, we're going to do the opposite of add the 16. We're going to subtract the 16. These cancel. This becomes 26. Okay, so we have 2x equals 26. The last step is to divide both sides by 2 to get rid of the 2. Canceling that out, making this 2 can go into 26 13 times and into itself once. So all we have left is x is 13. The value of x is 13. All right, let's read problem number 4. A horizontal line has a slope of 0. True or false? Show you this image here. This is called positive, slanting to the right, negative, horizontal, 0, vertical, undefined. So this statement is true. Okay, problem number 5. What is the slope of a line that runs parallel to y equals x plus 7? I wrote this out because this is what we call the slope-intercept form, where m represents the slope. So in this case, the slope is 1. If there's nothing there, then you know it's a 1, okay? And so our slope, this line the slope is 1. And according to this, slopes that are parallel have the same, lines that are parallel have the same slope. So if you want to know what is the slope of a line that's parallel to this, it's the same, 1. Okay, problem number 6. Simplify this equation. Actually, that is an expression. Simplify this expression. It's not an equation because it doesn't have an equal sign. Okay, all we have to do is combine like terms. This and this are like terms. 2 plus 1 is 3. And then you have this. These are like terms because they both only have y as their coefficient. Okay, 13 minus 2 is 11y, and it's positive, so you're going to put positive. Okay, problem number 7, rewrite this equation in slope-intercept form. Remember that this is slope-intercept form where you just have y, so it could be either one of these, equals the slope, m. So is our slope going to be 2/3 or negative 2, plus a y-intercept. So we got to figure out if our y-intercept is 6, 2, or 6. The first step was very easy. We just took this whole term and moved it across the equal sign. Doing that, the sign changed from positive 2x to negative 2x. The second step is very easy also. Since it's 3 times y, then when we moved the 3 over, it became divided by 3. The opposite of times is divide. Okay. In this step, it's the same as this, it's just separated. And then in this case, I can reduce this. So then y equals negative 2/3 x plus 2. And there you have it. Y, our slope is negative 2/3, and our y-intercept is 2. Problem number 8, which function is an example of exponential decay? Whole numbers, whether they're positive or negative, will be growth. Fractions or decimals will be decay. Let me show you this example. Would each equation be growth or decay? See the whole number? Growth. Whole number, growth. We got a decimal here. It's gonna decay. And we have a fraction. It's gonna decay. Decay. So out of all of these, the only whole number, we've got a whole number, decimal, whole number. This will be decay. Okay, problem number 9. Which of the following sequences is not arithmetic? You need to know that arithmetic sequences have a common difference and geometric sequences have a common ratio. Kind of looks like so in arithmetic sequences, you're either adding or subtracting a number, and in geometric, you're either multiplying or dividing by a number. I like to go this direction instead because it kind of shows the difference part. 4 minus 1 is 3, 3 minus 1 is 2, and 2 minus 1 is 1. This is a common difference. Same thing here. We subtracted 2 from each one. That's a common difference. In this one, if you add 2, you will get negative 6 plus 2 is negative 4. Negative 4 plus 2 is negative 2. You'll get the next sequence. So that is also known as a difference. Even though you're adding, you could be subtracting -2. But anyway, adding or subtracting is going to make it arithmetic. So this one's also arithmetic. Okay, on this one, every time it's a different number. It's not common. So this one is not arithmetic. Okay, problem 10. What is the common ratio of the geometric sequence? This is how I find the common ratio. I take this number and I put it over this number and reduce it. Let's see. Okay. 18 can go into 54 3 times, and 18 can go into 36 twice. 3/2. Okay, that would work. Putting this also, putting 36 over 24 reduces to 3/2 because 12 can go into both of these. And it also works putting 24 over 16 because, change that to 16, because 8 can go into here 3 times and 8 can go into here twice. So this is what I was talking about when I said common ratio. This is a geometric sequence because each term or step, they share a common ratio. Okay, problem number 11. I wrote it out. We're going to work it out. First, we've got to do the distributive property. We're going to multiply 6 by 2 and then multiply 6 by 3. Since it's -6, you're going to put -6 times +3 is -18, giving us -12n minus 18. Okay, so now we're just down to 2 steps. We just have to do the opposite of subtracting 18. So we're going to add it to both sides, canceling that out, making this -42 plus 18. Okay, -24. And hopefully you know what the last step is. It's the opposite of multiplication. So we're going to divide both sides by -12. Cancel that out. This becomes 2/1. So your n is 2. Okay, problem number 12. If m plus 2/5 equals 1/2, which of the following is true? And this one, since there's an equal sign between two fractions, I like to cross multiply. So 5. And then this way we're going to go. It's going to become 2m plus 4, because the 2 has to be multiplied by both of these. Okay, so we're down to 2 steps. We're going to subtract 4 from both sides to get rid of the 4. 2m equals 1. The next step is just to divide both sides by 2. Canceling out that 2. m is 1/2. Okay, so I got a little carried away. We didn't have to do from here down. All we needed to know was this right here. Okay, problem number 13. How many terms are there in this expression? Terms are separated by minus signs and plus signs. So this is 1, because it's being multiplied, that makes it a term. This is 1 term, because it's being multiplied. Those two make 1 term, and this is 1 term. So that's only 3 terms. Okay, problem number 14. All of the following points lie on the graph of y equals 4 to the power of x except what? Okay, so I already wrote out how each of these would look. Y is a 1 here, so I put a 1. Y is a 4 here, so I put 4, 16, 27. And then these x values are all the first terms. Those are always x values. And they go in the exponent spot. So we just have to go through and check each one of these on our calculator. This is where you're going to need your scientific calculator. and you're going to use this button right here to do different exponents. So let's say, what is 4 to the power of 0? You're going to 4 to the power of 0 equals 1. 1. So this is true. Okay, let's try 4 to the power of 1. It's still 4, which is true. Okay, the next one, 4 squared. 4 to the power of 2, 16. And that's what they have, 16. And then 4 to the power of 3. 4 to the power of 3. 64. And this says 27. So in this case, the answer is false, making this not. This point does not lie on this graph. Okay, on number 15, which of the following would you multiply both sides of this equation by n? Remember, to solve, we do the opposite. So what is the opposite of multiply? If you said divide, you were correct. So find out which one of these is division. That's the one you're going to be multiplying on. This is division right here. Okay, problem number 16. All of the following expressions are equivalent or equal except which one? I took the time to multiply 4 times x, 4x. 4 times negative 1 is negative 4. This is already complete the way it is. I just swapped these two, so it's positive 4x minus 4. And then I'm going to work this one out for you where I multiply the x by negative 4, giving me negative 4x. And then I multiply the x by a positive 4, giving me positive 4x. Making this one different from all of the rest because each of the constants have a variable with them. So it's definitely different. Okay, problem number 17. Convert 77 degrees in Fahrenheit to Celsius using this formula. I went ahead and substituted the 77 degrees Fahrenheit in place of the F. I like putting the variable that's by a fraction on top because that's what it's supposed to be. It's supposed to be with the numerator. Okay, so the 2 steps in solving this are going to be subtract 32 and multiply by 5. And then we're still going to have to get rid of the 9. I'll show you how to do that. I think I'm just going to change this fraction to a decimal. So I'm going to go 9 divided by 5 is 1.8. So instead of having a fraction here, I'm going to have 1.8c plus 32. Now I'm going to do the opposite. The 2 steps that are going to be opposite are subtracting 32 and dividing by 1.8. Okay, that gave us 77 minus 32 is 45. These canceled out, so all we have left is 1.8c. So to solve for this, we're just going to divide both sides by 1.8. Canceling this one out, and then we got to use our calculator to figure out what's 45 divided by 1.8, 25. Okay, problem number 18. What is the slope of a line passing through 6, 3, and 8, 7? You should have this memorized. M stands for slope, meaning rise over run, which are your y coordinates subtracted over your x coordinates subtracted. Okay? The first set is always your x1, y1. The second set is always your x2, y2. So all we have to do is substitute these numbers in place of these letters or variables. Okay? 7, y2 is a 7, x2 is an 8, y1 is a 3, and x1 is a 6. That gives us 4 over 2. That reduces to 2 over 1. And that finally reduces down to 2. Okay, problem number 19. What's the common difference or common ratio of this sequence? Remember on problem 9, we talked about arithmetic sequences have common differences and geometric sequences have common ratios. So you have to see what is there a common number that is being subtracted, or do we have a common ratio where we put the number over the one in front of it and it reduces, they all will reduce to a common ratio. This one's pretty easy. It's easy to see that if you subtract 5, subtract 5, subtract 5, that you're going to get the next number. So the common difference was 5. You don't have to put the subtract 5. You just put 5. Okay, on problem number 20, which table of values is correct for this equation? I took the time to go through and write the equation by each table of values because we have to substitute these numbers in each set of numbers into the equation to solve. Okay, on this equation I substituted the y as 3 and the x as 0. Okay, that gave me 3 equals 3 to the power 1, 3 times 1. How did I get 1 from here to here? Use your calculator. Take 2, put it in the power of 0, and you get 1. That's how I got the 1. So that worked out, which is great, but you cannot choose your table of values only by one set. You have to do at least 2 or 3. So let's move on to this, test this set of numbers out. Okay, it will look like this. The y is a 6 and the x is a 1. Okay, we have, it does equal, so we have 2 sets of numbers that equal this. Let's go ahead and test the last set. It would look like this. 12 is your y, goes here. And then your exponent x is a 2, that goes there. 2 squared became 4. 3 times 4 is 12. So all 3 of these equaled out in the end, making this a correct table of values for this equation. So thankfully we didn't have to do that one or that one or that one. But on the test you might have to do all 4 before you find out which table of values works for that equation. Okay, problem number 21, solve for b. The b is right here. What I'm going to do is start eliminating terms. I'm going to move this term over here. Once it crosses the equal sign, it becomes -3. Looking like this. Okay, the c is still here and it's still positive, but now the 3a is over here. Alright, now we just need to eliminate this 2. So since it's 2 times b, to solve we're going to divide both sides by 2. Looking like this. And then finally looking like this. B is finally eliminated and everything else that moved over here looks like this, matching this problem right here. Okay, problem number 22. Which graph has an x-intercept of 5 and a y-intercept of -3? Okay, first you need to know that this horizontal axis is always your x-axis and the vertical axis is always the y-axis. So look at the x-axis for 5. This one has a point on 5. No. Yes. No. These have x-intercepts on -5. So they're not, oh, and that's -3. So these are not going to work. Next, okay, next we need to look for a y-intercept of -3. That means look at this y-axis. Between these two, which one is going through -3 on the y-axis? Not this one. There's nothing going through -1, 2, 3. It needs to be right here. So this, it finally comes down to this one because it's going through the x-axis at 5 and the y-axis at -3. Okay, problem number 23. A 16-foot board is to be cut into 3 pieces. 2 of the pieces will be the same length and 1 will be 5 feet longer than the other 2. So we've got the 16-foot board cut into, I sectioned it off to 3. 2 of them are the same. Let's make, these 2 are the same. And the last one will be 5 feet longer, so we're going to put x plus 5. I know that doesn't look longer, that one looks shorter, but anyway. So we got to add these 3 sections to get the answer. Okay, so the equation is going to look like this, where we adding the 3 sides. First thing we're going to do is combine like terms. These are like terms. So we have 3x's. Okay, now we're down to 2 steps. We're just going to subtract the 5 from both sides, getting 3x equals 11. Our last step is going to be division, because that's the opposite of multiplication. Okay, we got 3 2/3, but LOL, because I got a little carried away. We didn't need all that information. All we needed was this information right here, which most closely matches this equation, because we're adding 3 x's and a 5 to get 16. We're not adding the 5 to the 16, we're not subtracting the 5, and we're not multiplying. We're adding the 5 to the 3 x's to get 16. I made that longer than it should have been. Okay, problem number 24. Which of the following equations is linear? First, let's go over this, that linear equations will not have the absolute value in them, and they will not have exponents other than 0 or 1 in them. So, not that one for sure. That might be a 0 or 1, I don't know. You could substitute that, I guess. But here's a picture of some examples of what linear equations look like and what nonlinear equations looks like. Nonlinear equations won't have exponents greater than 1. They won't have the square root sign. They will not multiply x and y together. That's a big no-no. And they will not have x or y in the denominator. Okay. In this case, it might look like the x is in the denominator, but it is actually 1/2 times x, which makes the x be in the numerator. So this is perfectly fine for a linear equation like this one is. So this is a no-no. That's a no-no, the exponent, and that's a no-no. So this is the only one that comes down to linear. Okay, problem number 25. What are going to be the next 3 terms in this sequence? First, we have to identify, does this sequence have a common difference or a common ratio? First, we're going to check, is there a number that is commonly being subtracted every time? 29 minus 6 is 23, right? 20. Okay, that was easy. The difference is easy to find. So there was a common difference, and it was 6. It was subtracting 6. All right, so moving forward this direction, we will be getting larger by 6 every time. All right, so we found out that the common difference is 6. So it's growing. So 29 plus 6 is 35, 41, 47. There's our final answer.